Hey, chemistry crew, Mr. Collier here. I want to talk to you today about molarity. Earlier in our chapter on solutions, we talked about the idea that a solution could be concentrated or it could be dilute. Molarity is where we get a lot more specific about how concentrated or dilute a solution is. This is on page 13 in your solutions packet. And really, I'm just going to explain what it is, and then we'll do some sample problems about molarity. So molarity is abbreviated with a capital M, and you're going to see that in our equations. And what molarity is it's the number of moles of solute per the number of liters of the total solutions. We can write that M equals N over V. Molarity equals the number of moles divided by the volume. And so the units are going to be moles per liter. So if we say something is concentrated, that is not very specific. But if we say it is 2 molar, that means there are 2 moles for every liter. And that is a lot more specific. So when we're doing sample problems, we can kind of tackle it this way. So we can say, what is the molarity of a solution formed by mixing 10 grams of sulfuric acid with enough water to make a 100 milliliter solution, right? So what we're going to do is we're going to first figure out how many moles of this solute, this sulfuric acid we have. So if we had 10 grams, that's not the number of moles, that's the number of grams. And since different chemicals have different masses, we want to be able to do apples to apples comparisons. We need moles, not grams. So we take the number of grams of that chemical and we multiply it by 1 mole over the molar mass of that chemical, which we get the molar mass from the periodic table. And that tells us how many moles of, in this case, sulfuric acid we have. And there's that many moles per 100 milliliters, but we're going to put it in the liters, right? Instead of 100 mils, we're going to call it 0.1 liters. So we've got 0.1 moles in 0.1 liters. So this is just about 1 molar. At this point, you're probably thinking, that sounds familiar. And that's because we've done a lot of labs this year where we've used different chemicals like hydrochloric acid, and the bottles always talk about their strength, their concentration, their molarity. They always say like 2 molar or 2M HCl on the bottle. So this is what that is, the thing we've been talking about. All right, so here is another example. How many grams of bromine are needed to prepare 0.5 liters of a 0.01 molar solution? So this is something you might do if you're prepping for a lab or prepping for an experiment. You want to know, how much of this chemical do I need to mass out to make the solution I'm looking for? So if M equals N over V, right, we're now going to rearrange this to solve for N. So we want to know the number of moles. So that's going to be the molarity we're looking for times the volume that we need. So we need 0.01 moles per liter, and we need 500 milliliters or 0.5 liters of it. Notice that the liters are going to cancel out, and we'll be left with how many moles of bromine we need. Now, one more thing. It doesn't ask me how many moles of bromine, because again, that's not a very useful value to have moles in and of itself. But what it can tell us is how many grams to measure out, which is something we can much more easily do in a lab setting. So now we take our number of moles that we need, multiply it by the molar mass, and now we know how many grams of this chemical we need to prepare that solution. Okay, so you can see this can be pretty useful in a lab setting. Another thing that we can do is we can talk about how to prepare 100 mils of a certain molarity, a certain strength solution. So in this case, potassium nitrate. So we want to know really, again, how many moles of this chemical we need. So we're going to do the molarity times the volume. So we know the molarity is 0.75. We know the volume we're looking for is 100 mils or 0.1 liter. And that means we need 0.07500 moles of that chemical. Again, now we want to know how many grams of that we get. So we multiply it by the molar mass. And we have the number of grams. Now that alone is not describing how you would prepare it. So now we want to get a little bit more specific. What we would do is we would take that 7.583 grams, we would add it to a volumetric flask. If you remember, volumetric flasks have markings specifically for amounts. So you just get a 100 mil volumetric flask and then fill water up to the line. If we filled it to 100 milliliters first and then added the chemicals, we wouldn't have a 100 milliliter solution. We'd have more than 100 mils because the potassium nitrate would displace water. So you got to add the chemical first, then add water up to the line. That's how you create a solution. One more example, and then I believe you are going to be ready to tackle the rest. This is still on page 13. What volume of 0.6 molar sodium hydroxide can be prepared from 4.8 grams of solute? So here you've got a certain amount of solute left. You want to make a certain concentration. You got to figure out how much to add. So now we're solving for V, right? We're solving for volume. So that's the number of moles divided by the molarity. So we're going to take the number of grams and convert it to moles first, because again, you got to work with moles in this. So we divide by the molar mass. That tells us how many moles we are starting with. So if we have 0.12 moles and we want to make 0.6 molar, we're going to divide them. The moles now are going to cancel out, and we'll be left with 1 over liters, which is liters. That'll tell us the volume we can make, which is 0.2 liters. So we can make 200 mils of this. And I believe that's it. We're not going to talk about dilutions until next time. So let me know if you have any questions, and have a good one.